Hello, Prob Stats, and welcome to Chapter 3. We're going to be talking about measure of center today. We will be using StatDisk quite a bit and a little bit on the calculator, so make sure you have both of those ready to go and your note packet, and let's have a little bit of fun. All right, measure of center, it's just telling you what the center of the data is. There's 4 different types of measure of center. There's the mean, which you guys probably would have known as the average, the median, which is the middle, mode, are the ones that occur the most often. There can be more than one mode, and the mid-range, all right, or the middle of the data. Okay, we're also going to determine if there's any outliers today for real, like how do we actually check if there's an outlier and how to get rid of them, and how this affects our 4 modes or our 4 measures of center and what that does to them. All right, measure of center, when you're looking through here, is a value at the center or middle of the data. All right, so measure of center is just the center or the middle of the data, nothing exciting. The mean is technically called the arithmetic mean because we calculate it by adding. It's a set of data, the measure of center found by adding all of the data values and dividing by the total, which we have done before also. Properties of the mean, which are very important. Okay, they are from the same population. They tend to vary less than other measures of center. So if you take the same population and you have 4 or 5 samples, your mean will not be the same as a population, but it will be close. It uses every data value, not just a few of them, which is very nice because it uses every data value. None of them are excluded like some of our other measures of center. The disadvantage, if there's just one extreme value or an outlier, it changes it. That means it is not resistant. All right. Resistance is if the presence of an extreme value does not cause it to change. All right. Unfortunately, the mean is not. It is changes drastically when we have outliers. The median, or the middle of the data, original values have to be arranged in order, increasing or decreasing. Usually we do increasing. Does not change by large amounts when we include a few extremes values. So the mean is resistant, all right, to outliers because it's just the middle piece. The bad part is it does not use every data value. So it doesn't tell you what's going on between the two. Mode. Unfortunately, a lot of you have been always taught that the mode is the one that occurs the most. That is not the case. It has the greatest frequency, but there can be more than one mode. So if you have 2 or 3 things that occur 5 times, all 2 or 3 of them are considered to be the mode. It can also be found with qualitative data. And this is just telling you there's more than one mode. It is also resistant to outliers. Mid-range. So you know how to find the range of a thing. You just go from the largest minus the smallest, correct? That gives you the range. The mid-range is you take the max data value plus the min data value and just divide by 2. Gives you your middle, right? So nothing in the middle. It only uses the maximum and the minimum values. Because of this, it is not resistant. So just like the mean, the mid-range is also not resistant. All right, measure of center is one more decimal than the original data values, nothing new. The mode, you don't change. You leave it because it's actually one of the values in the thing. Again, our notation, nothing too new here. X is sum. X represent the individual data values. All right. N, the number. So X is the data values. N is the number of data values. Capital N just means it's of a population. This one up here was of a sample. X bar, all right? X bar is the mean of a sample, all right? X bar is always found finding the sum divided by how many you have. X bar is how that's read. Mu, I usually use this here for both, but it's technically not correct, is the mean of the population. X tilde means median. So remember, X bar is mean, tilde is median. Median you found, you got to sort them. Now remember, it's the middle term. If it's odd, it's just the middle term. If it's even, you have to take the two middle terms and divide them by 2, or add them and divide them by 2. All I'm hoping is old. All right, I would like you to find the mean, median, mode, and mid-range of the following data set. So pause and please do that. All right, to find the mean, I put mine in order because we'll need to do that for the median. I hope you add them and you divide it by 5. So your mean, or X bar, should have been equal to 12.2. Next, you should have taken and find the median, or the middle. So you were crossing them off, right? Last, first, middle, and you should have gotten also 12.2. Which is, I'm sorry, I forgot to write that down. X tilde. Okay, mode are the ones that occur the most often. In this case, you had 2. You had a 12.2 and a 12.3. Mid-range, you found by taking the first number plus the last number and dividing it by 2, and you should have gotten 12.2. Now next they said, hey, replace your lowest with 8.2. So over here, we replaced the 12.1 with an 8.2. This is to help demonstrate resistance. So when you calculated your mean, and you added and you divided by 5, you should have gotten 11.4. See how they are very different? Since they are very different, it is not resistant. Okay, the next one you should have calculated was your median. And when you looked at your median, you also got 12.2 because it's just the middle term again, right? And the exact same thing happened for your mode. You still had 12.2 and 12.3. Both of these are resistant because they do not change with the value of an outlier. Next is the mid-range. And when you did the mid-range, you should have taken the lowest, which now would be the 8.2. And you got 10.25. Also very different. So this is not resistant. Oh, I can't write this morning. All right. Now, when you're going through this here, not all measures of center are valid calculations. They don't all tell us something about data. Decide which measure of center is valid for this. So I've got Harvard, Yale, Duke, Dartmouth, Brown. All prestigious are your Ivy League schools, correct? All right, and they were ranked in the U.S. News and World Report. I would like you to calculate the mean, median, mode, and mid-range, and tell me which ones make sense. So pause and do that. All right, when you calculate them, you should have got 7.2 for the average, 7 for the median. There was no mode, and the mid-range was 8. Okay, which one of these don't make sense to do? Well, the averages are the mean is actually very nice. It tells us what they, on average, what they score. So I know if I'm below or above by looking at this. So this is a good one. We would like that. The middle value, probably not so much. We don't care who's in the middle. Just by numbers, because we could have outliers and it does not affect that. So no, not helpful. The mode is not helpful. Now the mid-range, high minus low. Again, also not helpful in this case. A little bit, but not near as much. The one that we really and truly like right here is the mean. Okay, now when we calculate the mean of a frequency distribution, remember those? Okay, you have to multiply each frequency by the class and then add the products. And then you divide by the sum of the frequencies. So let's try one of these. Here's our McDonald's lunch times from a couple chapters ago. All right, we have our classes written down here, our frequency of how often they had. So to find the class midpoint, we took 75 plus 124 and divided it by 2, and these are our midpoints. Okay, so this is step 1. This is how we find my x. All right, now I take the frequency times x, so you're multiplying these two together. So this frequency gives me this, and we add those up, and we get 8,025. Now I have to divide by my total frequency, or how many data values do I have. So we take and divide, we put this in, and we find our mean is 160.5 seconds. So on average, you're going to wait 160.5 seconds when you go through this McDonald's drive-thru. All right, I want you to do the exact same thing, but now I want you to add 10 to the midpoint and then calculate the mean, and let's see what we get. So pause and play. All right, so first you did is you added 10 to each midpoint right here, and you got 109, 159, 209, and so on. Next, you multiplied these two. You should have 1204, 3828, 2095, 778.5, and 619. Adding up, you got a total of 8525. Now, when you take the 8525 and you divided it by 50, you should have gotten 170.5. It increased by 10 seconds, correct? So all we have to know, if I said increase by 10 seconds, all we have to do is increase the average by 10 seconds, which totally makes sense because we increased everybody by 10. Should not have been a surprise. Okay, calculated a weighted mean. So when you do a weighted mean, you take the weight times how many you have, divided by the total number of weights. Now, let's see if I can explain this. We're going to use GPAs because this is something you deal with all the time. Okay, the author here had a daughter and she went to college, right? Her final grades were, she had an A for 3 credits, another A worth 4 credits, a B, a 3-credit course, a C, a 3-credit course. Then her 1-credit course she didn't care about and got an F. Life is good. Okay, just like ours, it's a 4-point scale. So we have an A is worth 3, a B is, 4, a B is 3, a C is 2, a D is 1, and an F is worth nothing. Now, how do you calculate your GPA? All right, we can still see. So the number of credits as weights. So A is 3. So this in here was her class 1. Class 2 was 4 credits. Her third class was 3. Her fourth class was 3. And then her fifth class was worth 1 credit. So probably her intro to freshman. Okay, replace the letter grades of A, B, C, F with their value. So now I have 3 and she got an A. So this is 3 times 4. She had 4 credits and she got, what did she get on this? Oh, another A. So 4 times 4. Then she had 3 credits and she got a B. So that's worth 3. She had 3 credits and got a C. So that one was only worth 2. And then she had 1 credit and it got an F and was worth nothing. So this here, the first number is credits. The second number is the weight. You multiply those all up. This in here is her weights right here. Sorry, 3, 4, 3, 3, 1. So now we multiply and add. We get a 43 divided by 14, and she has an overall GPA of a 3.07. Not bad. Okay. Same question, Lamar's. We use the same grading scale if they receive the following. So pause and try yours. All right, I hope you did well. We had 5 credits at a B of 3. We had 3 credits at an A, which was worth 4. We had 4 credits at a C, which was worth 2. We had 3 credits again at an A, which is worth 4. Divided by her total number of credits. So 5 plus 3 plus 4 plus 3. She had 47 over 15, so this person has a 3.1 GPA for this semester, or that current semester. All right, good luck on your homework. I hope you do well, and we'll see you tomorrow.